Now, we are going to take a look at, applying some of the information that we've got. These are only formulas. So, what I want you to make sure that you have are these formulas written down. Again, this is a situation that I want you to be able to apply them, not memorize them, and know which ones are which. Now, this one here is future value of an investment with annual compounding. Just compound it annually. P dollars principal, that's how much you put in, and S is what you're going to get out. Now, this is basically how we go through and calculate out interest. Future value, we are trying to figure out how much it's going to be in the future. Now, this is the one with compounding periodically. We've taken a look at things like this before. Compound interest. Again, make sure that you have that formula written down. Now, one of the things that we've got here, this is a chart that shows you what is happening as we compound things more. So annually, I compound that, it doubles my money. Well, that's nice. Quarterly, it's a little bit better. Monthly, daily, hourly, each minute. And then what we get down to is going to be continuously. But take a look at that number that you see there. We got 2, 2.4, 2.61, 2.71, 2.718, 2.7182. If you take a look at your calculator when you've been working with that value of E, you'll notice that that's it right there. Value of E, 2.182, and keeps on going out there. Now, there's another formula that I need you to make sure that you have written down. I generally refer to this one as PERT, P-E to the R-T. This is a continuous growth model. So when we're talking about money, this is continuous compounding. I have yet to run across any financial institution that even so much as closely comes by this. When I take a look at this, you'll notice that if you go and invest something, put it into a savings account, CD, more often or not, you will get quarterly interest. Loans, monthly interest. Notice how the banks are coming out ahead. They give you quarterly, they compound it monthly. You get to a credit card, and they will compound an annual daily balance. If you take a look at those numbers, that's not, doesn't seem to be a lot, does it? What happens over the course of time? Lots of time, lots of money. That can turn out to be a very, very large value. So, another formula that I want you to make sure that you have is present value. Now, you have to understand what it means when we say present value, what this is calculating out. The other ones were future value. That is how much is it going to be worth in the future. Okay. Now, the present value, the lump sum that will give future value S in a compounding periods at rate I as it goes through. What this is looking for is how much money do you need now, compounded at a specific time interval, so that you have this amount of money in that time. So what I want to do here is I want to kind of walk through this one here with present value so that you can see what's going on with it. We've worked with the other two or the other ones before, and you've done interest and all those other wonderful things. Now we're going to take a look at something going the other way. Okay. If I want to put this in context, say, for example, that in 7 years you want $15,000 to buy yourself a car, and you're going to save up for this. Okay. That works great. You've got 7 years of time to do it, and you want it, and whatever investment that you have is going to be compounded at 10%. So, we'll grab this. Come on, there it goes. It's not the time for my computers. Sorry, it's not good. So, lump sum that will give you that value S. So what do I want? Do I want to know the money that I need now or the money that I am going to have in 17 or in 7 years? What does that $15,000 represent? Now or later? And since it's representing later, they will almost always, the variable in these type of equations, P, will represent principal, that amount you put in to begin with. S is what you get out, future value. So as I set this one up, P is going to be equal to 15, 1, 2, 3, 1 plus. What is my interest rate? 0.1. How many periods am I going to compound that? Well, I'm compounding it semi-annually, correct? So if I'm compounding it semi-annually for 7 years, how many times is that? What is semi-annually? Well, if you need to, go back to your little table up over here. Annually, quarterly. Doesn't have a semi-annually. Well, what does semi mean? Half or part. And in this case, semi-annually does mean 2, so that how many times would it be compounded? Twice a year. For how many years? 7 years. So how many periods do I have? 14. So now that I have got that written that way, all it's going to be simply is a calculator exercise. Grab the calculator. And I'm going to have 15, 1, 2, 3, divided by parentheses. Now, just so that I make sure that I keep all my stuff in my denominators, I'm going to put in this as follows. 1.1, because that's added together, correct? Raised to the 14, close it. Highly recommend putting in your denominator in a set of parentheses so the calculator knows exactly what you're looking for. So, this tells me that I am going to need 3,900, roughly $3,950 now. If I had that much money now and just let it sit for 10 years or for 7 years, at 10% interest, compounded semi-annually, I would have $15,000 by the end of that. That seems to make sense, doesn't it? Basically, all it's doing, it's working backwards this idea of future value. In other words, what you would normally go and invest, it's just working it backwards. But rather than trying to develop the formula, they give it to you to begin with. Okay. So, do you see a problem here? I followed everything correctly, didn't I? I didn't get the same answer they did. Do you see anything in here that's making an error? I see. I what? I got to use 0.05 instead of 10? Well, why is that? Okay. Generally, this is what throws students because they're so accustomed to having I, meaning the interest, and we just go there, but they don't pay attention to one little bit. Per period. Okay, is the rate per compounding period. Now, 10% is the annual interest. Okay, how much is it going to be for a period? Well, I got to divide that by 2, right? So this really shouldn't be this in here. It really should be 0.05. Usually they go and put that in the formulas. They tell you how many times it's being per year, divided out per year. If we go back and we take a look at the compounding that they do up here, it's a formula, it's a formula. Notice how they've got this K down here, and K is identifying the times per year that it's being compounded. We have to apply this here as well. Okay? It's just that they don't necessarily put that into the formula that way. They go and calculate it out per period in a year, divide it, and go. So now, watch what happens. If I go and take my 15,000 again, divided by parentheses, 1.05, close it, raised to that, whoops, hold a second, wrong place, raised to the 14, close it. Now, do I get the value that they expected? As I said before, more often than not, this is the error that students make. They don't go through and read the situation that says the rate per period. So we have to divide that out. Like I said, if you're going to make a mistake, that's usually where it applies at. It appears. So, with that in mind, I am going to let you get to work on this so that you can ask questions. But remember, have the formulas, plug the values in, and go from there.